Hello students, myself S.K.Jadhav from Department of Electronic Science, KTHM College, Nasik. I am going to teach you the subject of S.Y.B.Sc Electronic Science, paper number 2nd. Subject code is EL-232, Digital Circuit Design. The syllabus of this course includes total 4 units. Unit 1 is Logic Families. The contents of Unit 1 are revision of logic gates using diodes, transistors, and MOSFETs. Introduction to logic families and its performance parameters. Comparative study of TTL, CMOS, ECL with reference to performance parameters. Then second unit is combinational logic circuit design. The contents are OR gate for event detection, AND gate for frequency measurement, XOR gate for parity generation and checker, NOT gate for square wave generator, NAND gate for key debouncer circuit, design of code converters using K-maps, that is BCD to 7 segment display, concept of adder using look ahead carry generator, keyboard encoder circuits, priority encoder, and error detection technique, that is Hamming code. The third unit is sequential logic circuit design. The contents of third unit are state table, state diagram, excitation table, and transition table. The second topic is design of counters using state machines, a synchronous, modulus, and up-down counter, design of sequence generator. And the last unit is data converters. The contents are revision of data converters such as R2R data converters, that is R2R digital to analog converter circuit, then binary weighted data converters, then ADCs such as counter type ADC, successive approximation ADC, flash ADC, and dual slope ADC. The last topic is comparative performance analysis of ADC by using ICs like 0808, 0804 and IC 7106 and digital analog converter ICs such as 0808 and 0804. This course provides basic knowledge about systematic methodology of designing digital systems. After studying this course, you will be able to distinguish between different logic families based on their performance parameters. You will analyze basic combinational logic circuits for simple applications. Then design of combinational logic circuits using K-maps for some well-known applications. We will also study design of sequential logic circuits using state diagram, excitation table for identified applications. And you will understand and compare different types of ADCs and DACs by using their performance parameters. Let us now, we will start our first chapter, that is unit number 1, logic families. In this chapter, you will learn logic gates using diodes, transistors, and MOSFETs, logic families and its performance parameters, and comparative study of TTL, CMOS, ECL with reference to performance parameters. In this module, we will emphasize on the basic operation of logic gates using diodes and transistors. You will learn about the basics of logic gates such as AND gate, OR gate and NOT gate, and why are they referred to as fundamental building block of any digital system. The operation of logic gates will be explored using switch analogy and also using discrete components such as diodes and transistors and its corresponding truth table. In addition to this, simple applications of logic gates will be explored. Let us begin the discussion of logic gates through a simple question, that is, what is a logic gate? A logic gate is a basic building block of a digital circuit from which most of the digital systems are built up. It is capable of performing a particular logic function by operating on a number of binary inputs to make the decision. These are the circuits used to process digital signals. That is, they are binary in nature. Logic gates basically follow the Boolean algebra. It accepts binary inputs like it could be 0 or 1, true or false, or it could be high or low. Logic gate is a digital circuit having one or more than one input but with only one output. Most logic gates have two inputs and one output. The output appears only for certain combination of input logic levels. At any given instance, every input or output terminal is one of the two logic conditions, that is, true or false, which describes logic value. The numbers 1 or 0 provides value present the two possible states of a logic circuit. High and low describes the voltage levels, and on and off describes the switch position. Then why do we need to study logic gates? Study of logic gates can help you to understand the operation of logic circuits. In addition to that, clear understanding of the operation of the logic gates can help you to construct different complex logic circuits. With the help of the understanding of logic gates, you can analyze the signal flow in the logic circuit. Then, where do we use logic gates? Or what are the applications of logic gates? This question will help you in identifying the applications of the logic gates. Logic gates find applications in number of digital devices or digital systems and digital products. Logic gates are used in constructing various logic devices like multiplexers, demultiplexers, code converters, arithmetic and logic unit of computer, that is ALU. They are also used in microcontrollers, microprocessors. Every digital electronic gadgets like personal computer, laptop, tablet, mobile phones, calculators, digital watches, LED and LCD TVs, all these are constructed using logic gates. It is also used in safety thermostat, in an automatic watering system. They are also used in push button switches, for example, doorbell. They are used in the functioning of street lights. NAND gates are used in light activated burglar alarms and buzzers. The application of AND gate is it is used to enable or inhibit or disable the data transfer function. Types of logic gates. Logic gates are classified into three types. Basic logic gates, that is AND, NOT and OR gate. Universal logic gates, that is NAND gate and NOR gate. And the third type is other logic gates, that is XOR gate and XNOR gate. Basic logic gates. There are three basic operations in digital systems. It provides three basic logic gates that make up a digital system are OR, AND and NOT gates. The relationship between the inputs and outputs is based on certain logic. All the possible inputs and outputs of a logic circuit are represented in a table called truth table. Logic gates basically perform some basic logic functions such as ANDing, ORing, and inversion. Let us now discuss these logic gates. Now, we will discuss the basic logic gates using discrete components such as diodes, transistors, resistors, and switches. Let us now discuss the operation of OR gate. That means OR gate using switches and diodes. The definition of OR gate is OR gate has two or more inputs but only one output. It is known as OR gate because the output is high if any one or all of the inputs are high. The logic symbol of two input OR gate is shown in figure A. The OR gate performs logical addition. The Boolean or logical expression to represent OR gate is given by y is equal to a plus b, and plus symbol indicates, or the plus symbol, it should be read as OR. The second circuit shown in figure B by using switches. The OR gate can be thought of like an electrical circuit, which is shown in figure B, in which switches are connected in parallel with each other. Let us now consider an electronic circuit consisting of battery, switches, resistor, and lamp to explain the OR gate function. Referring to the switch analogy, when both the switches are open, that is A and B both are open, that means at zero level, then no current flows from battery to lamp. Thus, lamp is off. That means output of OR gate is at logic 0. When one of the switch is closed, that is at level 1 and other one is open at 0 level, the lamp is on, indicating that logic 1. That means the output of OR gate is high or at logic 1. As the circuit is complete, the current flows from battery to lamp, thereby turning the lamp on. Similarly, when both the switches are closed, that is, both inputs of OR gate are at logic 1, then the circuit is complete. Therefore, current flows from battery to lamp, which in turn makes the lamp on, and an OR gate produces a high output. That means the lamp will glow if both inputs are closed or any one of them is closed. Let us now discuss the OR gate by using diodes. Figure shows the two input OR gate by using diodes D1, D2 and resistor. Let us now we will discuss the working of the circuit. When both A and B are at 0 level, that means A equal to 0 and B is equal to 0, or A and B both are connected to ground or low level, the output voltage will be low because the diodes are in non-conducting state. That means the diode will go into the reverse bias and therefore there will be no current flowing through the circuit. In terms of binary, when A equal to 0 and B is equal to 0, then at that time Y is equal to 0. When A is low, that means connected to ground, and B is high. It is shown in truth table. A equal to 0 and B is equal to 1. That means B is connected to the positive terminal of the supply and A is connected to ground. Then diode D2 is forward bias and D1 is reverse bias. That means D1 remains in non-conducting state and there is no current flowing through the diode D1, but D2 is in forward bias condition and therefore current will flow through diode D2 and also through resistor RL, and output is high and the voltage is ideally equal to plus 5 volt or equal to VCC. In terms of binary, when A equal to 0 and B equal to 1, then output Y is equal to 1. Now the third case is A is equal to 1 and B equal to 0. When A is high, that means connected to the positive terminal of the battery, and B is low, that means connected to ground, then diode D1 conducts, that means diode D1 will go into the forward bias condition and D2 remains off, so that current flows through resistor RL and the output is high. Again, the output voltage is ideally equal to plus 5 volt or equal to VCC. In terms of binary, when A equal to 1 and B equal to 0, then Y equal to 1 as shown in the truth table. Then the case number 4 is A equal to 1 and B equal to 1. When A and B both are high, that is, both are connected to the positive terminal of the battery, then both diodes, that is D1 and D2, are conducting. That means D1 and D2 both are forward bias condition. Both diodes are on and therefore the output is high. Since the diodes are in parallel, the output voltage is plus 5 volt. In terms of binary, when A equal to 1 and B equal to 1, then Y is equal to 1 as shown in the truth table. That means we can say that the OR gate produces a logic 1 if either 1 or both the inputs are at logic 1. Here we conclude operation of OR gate using diode and switches. In this lecture, we have learned the basic logic gates, definition of logic gate, applications of logic gates, and working of OR gate using switches and diodes. In the next lecture, we will continue the operation of AND gate using diodes and NOT gate using transistor.